Have you ever just stopped and wondered, how did any of this get here? Not just people or trees or animals, but the very first, tiniest spark of life. Well, that's what we're tackling today. One of the absolute biggest questions there is. Where did life come from? I mean, really think about it. Our planet wasn't always this beautiful blue and green world. It started out as a hostile, lifeless, scorching ball of molten rock. So the question is, how on earth do you get from that to this? That's the incredible story we're going to unpack. And to do that, we have to rewind the clock a lot. We're talking 4.5 billion years ago. That's when our planet was first born, spinning out of this giant cloud of gas and dust. Our story literally begins at the dawn of the Earth itself. Okay, so let's try to picture this early Earth. Honestly, you wouldn't even recognize it. It was a totally alien place, hot, covered in volcanoes, and constantly being slammed by asteroids and comets. But, and this is the key part, somewhere in all that chaos, the raw ingredients for life were starting to come together. The atmosphere back then was just this simple cocktail of atoms. You had all the heavy hitters for life: hydrogen, oxygen, carbon, nitrogen. The exact same stuff that makes up you and me. The only thing is, they were just floating around as simple individual atoms. And here's the kicker. There was no ozone layer, no protective shield from the sun's intense radiation. So, okay, you've got your basic ingredients, you've got a ton of energy from the sun. The next big question is there a recipe? Is there a set of steps that could turn all that chemical chaos into something ordered, something alive? Well, modern science thinks so, and the leading idea has a name. It's called the Oparin-Haldane theory, and it's really the foundation for how we think about the origin of life. The main idea here is that life didn't just pop into existence all at once. Nope. It was a slow, gradual process they called chemical evolution, where simple, non-living stuff slowly, step by step, became more and more complex. And this process can be broken down into 4 main stages. First, you start in the atomic phase with just those loose atoms we talked about. Then, in step 2, those atoms get together to form simple, inorganic molecules, things like water or ammonia. But then comes step 3, where intense energy forces those simple molecules to form simple organic molecules. These are the building blocks. And finally, step 4, those blocks start assembling into the very first living systems. So what was the engine driving all this? Well, remember that missing ozone layer? That was actually a good thing. It meant the early Earth was just getting zapped by all kinds of high-energy radiation from the sun. UV rays, X-rays, you name it. Plus, you had constant, massive lightning storms. This incredibly harsh environment provided the raw power needed to mash those simple molecules together into something new. Now, as all these reactions kept happening, over millions and millions of years, the ancient ocean started filling up with all these new organic molecules. One of the scientists, J.B.S. Haldane, came up with a perfect name for it: the prebiotic soup. It's like the whole planet was one giant chemistry experiment, just simmering away. Now, that is a fantastic theory, right? A clear, step-by-step recipe from atoms to life. But in science, a good story isn't enough. You need proof. You need evidence. Could anyone actually test this wild idea and see if it held up? And really, that was the million-dollar question for a long time. Is it even possible to create the building blocks of life, things like amino acids, from just a few simple gases and a spark? It honestly sounded a little too good to be true. And then came 1953. At the University of Chicago, a young scientist named Stanley Miller, along with his professor Harold Urey, decided they were going to put this theory to the ultimate test. They were going to try and build a little baby Earth right there in their lab. Their experiment was just beautiful in its simplicity. They basically took a closed loop of glass flasks and tubes. They filled it with the gases they thought were in the early atmosphere: methane, ammonia, hydrogen. They boiled some water to add water vapor. And then, to simulate lightning, they just zapped the whole mix with electric sparks. And then they waited for just 1 week. The result was, and I am not exaggerating, absolutely world-changing. After that 1 week, the water at the bottom of the flask had turned this murky reddish-brown color. And when they analyzed that gunk, they found it was full of organic compounds. And most importantly, they found amino acids, the fundamental building blocks of proteins, which are essential for every living thing we know of. So let's be super clear here. The crucial point is that Miller and Urey didn't create life in a test tube. But what they did was maybe even more important. They proved that the building blocks of life could form naturally, all on their own under the conditions of the early Earth. It wasn't a 1 in a billion miracle, it was just chemistry. Okay, so the Miller-Urey experiment gave us the ingredients, the building blocks. The next part of the story, the biggest leap of all, is how did those blocks, just floating around in the prebiotic soup, start to assemble themselves into the first actual cells? It's a huge puzzle that scientists are still working on, figuring out how they linked up into chains and, crucially, how they learned to make copies of themselves. And this timeline just puts the enormous scale of it all into perspective. Earth forms, and then it's about another 500 million years before the very first hints of life show up. By 3.8 billion years ago, we see the first real cells, these super simple little things called prokaryotes. But get this, it then takes almost another 2 billion years before the more complex cells, the kind that make up you, me, and every plant and animal, finally evolve. It's a story of incredibly patient, gradual change. Which brings us to one final mind-bending thought. We've seen the basic recipe, right? Take some common elements, add some water, hit it with a bunch of energy, and wait. The thing is, those conditions might not be all that special. So if this incredible journey from rock to respiration happened here, it leaves us with the biggest question of all. Could it be happening right now on countless other worlds all across the universe?